I'm Mary Swarnalatha, working as in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on the expectations and transformations of multiple random variables. First problem is the joint density function of two random variables x and y is fxy of x comma y is equals to x plus y whole square by 40 when x is from minus 1 to 1 and y is from minus 3 to 3. And it is 0 for other values of x and y. Find the first one, the variances of the random variables x and y. And the second bit, the correlation coefficient of the random variables x and y. So now what they have given? So they have given the density function of two random variables x and y. So which is given by what? X plus y whole square by 40 when x is from minus 1 to 1 and y is from minus 3 to 3. And it is 0 for other values of x and y. Next, what you have to calculate? You have to calculate the variances of x and y. So, what is the variance of x? Nothing but sigma x square. What is the definition of the variance of the random variable x? Nothing but expectation of x minus x bar whole square. Here, x bar is nothing but the mean of the random variable x. This is represented by mu x also. So, if you simplify this, you will get u of x square minus x bar whole square. So, this is the variance of x. And similarly, the variance of the random variable y is nothing but expectation of y minus y bar whole square. So, if you simplify this, you can obtain expectation of y square minus y bar whole square. So, this is the first bit. And second one, you have to calculate what? The correlation coefficient of the two random variables x and y. So, what is the correlation coefficient of the two random variables x and y? Which has been defined by rho xy. It can be defined by cxy also. Is nothing but what? Cxy by sigma x into sigma y. Rs can represent, this is by covariance of x comma y by sigma x into sigma y. Rs can represent sigma xy by sigma x into sigma y. So, where cxy has nothing but covariance of x and y, which can also represent what? Sigma xy. How it is defined? The covariance of the random variable cxy as sigma xy is equals to what? Rxy minus x bar into y bar. What is Rxy here? There is nothing but expectation of xy minus x bar into y bar. So, Rxy is nothing but what? Correlation. So, what is Rxy represent? This represents a correlation between the random variables x and y. So, minus x bar into y bar. Rx can write this as what? Expectation of x minus x bar into y minus y bar. So, this is nothing but what? Definition of the covariance of two random variables x and y. And what is sigma x? Nothing but what? Square root of the variance, the standard deviation of the random variable x. And what is sigma y? Which is a variance, the standard deviation of the random variable y, which can be obtained by taking the square root of the variance of the random variable y. So, these are the formulae to calculate the corresponding values like variances as well as the correlation coefficient. Now, we will solve the problem. So, what they are given, the density, the joint density function of two random variables x and y is given by x plus y whole square by 40 when x is from minus 1 to 1 and y is from minus 3 to 3 and it is 0 elsewhere. So, previously what are written here? What is the variance of the random variable? So, expectation of x minus x bar whole square, then ultimate what? U of x square minus x bar whole square. So, this you can write in terms of the moment, the joint moments about the origin. So, what is u of x square? Nothing but m2 0 minus what is x bar? Nothing but u of x, nothing but what? m1 0. So, therefore, what is the variance of the random variable? We can write down sigma x square equals to what? m2 0 minus m1 0. And similarly, what is the covariance? Can write down nothing but Rxy. What is Rxy? Nothing but what? M11. Nothing but expectation of xy. Minus what is x bar? M10 into M10. So, this is nothing but what? The calculation of the variance as well as the covariance in terms of what? The joint moments about the origin. So now we have to calculate what? M2 0. Similarly, we have to calculate M2 M1 0 into M0 1. And similarly, you have to calculate sigma y square. What is sigma y square? Nothing but M02 minus M01 whole square. Here also, because nothing but x bar whole square. What is x bar? Nothing but expectation of x. Therefore, M01 whole square. Now, what is the joint moments about the origin formula? M and k is nothing but expectation of x power m into y power k. This is nothing but what? Joint moments about the origin. Now, in order to calculate the variance, what you have to calculate? You have to calculate M2 0, M1 0, M02, M01 as well as M11 you have to calculate. Now, we'll calculate this one. So, first you'll calculate M. So, expectation of x power m into y power k. So, what type of random variables x and y here? They are the continuous random variables. So, for continuous random variables, so what is expectation of any function? For example, here in place of this I have taken the function g of x. Then what is the formula? Integration minus into infinity g of x into the density function of that random variable. So this is for single random variable. For two random variables, let us say g of x comma y is a function of two random variables. Then how can you find out the expectation of that function? So since you have two random variables and the two random variables are continuous type, you have to take the double integration. So integration minus infinity. So whatever that function you have added here. So it means u of x comma y into the joint density function f x y of x comma y into dx into dy. So this is for what? Single random variable and this is for what? Two random variable. Similarly here in place of g of x comma y, what do you have here? X power m into y power k. Then what is the expectation of x power m into y power k? Since you have two random variables, I have written here double integration. So minus integration minus infinity, integration minus infinity, x power m. This is x power m. So x power m into y power k into the joint density function of those two random variables x and y. So what is the joint density function of the two random variables x and y? Nothing but fxy of x comma y. So into dx into dy. So first we'll calculate M20. M20 is nothing but what? Here n value is 0. Sorry, here n equals to what? Here x power n. So n equals to 2 and what is the k value here? 0. So substitute here n value 2 and k value 0. Then what can happen here? Expectation of x square into y power 0. What is y power 0 value? 1. So expectation of x square is nothing but what? Integration. What are the limits of y here? Minus 3 to 3. What are the limits of x here? Minus 1 to 1. So write down the limits of x and y. And after that, so expectation of any function means you have to write down this function into what? Here k equals 0 and n equals to 2. So x square into y power 0. Nothing but what? X square. Into fxy of x comma y. In these limits, what is the density function here? X plus y whole square by 40 into dx into dy. Now that equals to, so what is can here 1 by 40 is constant, you can bring it outside. Then 1 by 40 into integration. Here y is equals to minus 3 to 3 and x equals to minus 1 to 1 x square into, write down here a plus b whole square formula. So a square plus 2ab plus b square, like that x square plus 2xy plus y square into what you have here dx into dy. So if you simplify this, then you are going to get the answer 9 by 25. Therefore, what you have substituted here? Calculated M20. So what is M20? Expectation of x square into y power 0. It is nothing but what? Expectation of x square you have calculated. What is that value you got here? 9 by 25. Next, we are calculating what? M11. So what is M11? Is nothing but expectation of n is equals to 1 and k is equals to 1. So expectation of x power 1 into y power 1. So here what? N value 1 and k value is also 1. So M11 nothing but expectation of x into y. So which is also called as actually the correlation between the two random variables x and y, which has been represented by what? Rxy. So what is Rxy? The expectation of xy is equals to integration minus 3 to 3. This is a y limit and similarly the x limits are from minus 1 to 1. And here expectation of xy. So here I done here xy into the joint density function. What is joint density function here? X plus y whole square by 40 into dx into dy. Now if you simplify this integration, then you are going to get the answer as 0.6. Therefore, what is m11 equals to 0.6. So next you will calculate m02. So what is m02? Nothing but n value is 0 and k value 2 in m suffix n comma k. Nothing but join moments about the origin of the order n plus k. Then what can happen here? Expectation of x power 0 into y square. So what is x power 0 value is 1. Therefore, it is nothing but expectation of y square. So therefore, what is expectation of y square is equals to, what are the limits of y here? From minus 3 to 3. The limits of x is from minus 1 to 1. And here, x power 0 into y square. Nothing but what? Y square only. Therefore, here y square into the joint density function. The joint density function given here, x plus y whole square by 40 into dx into dy. Now we just simplify this x plus y whole square as what? X square plus y square plus 2xy, and then simplify the integration. Then you are going to get m02 value, nothing but 5.16. So now what you have to calculate? The first bit you have to calculate the variances of the random variables x and y. So what is the variance of the random variable x? Nothing but sigma x square is equals to what? Expectation of x square minus expectation of x whole square. So what is u of x square? Nothing but m20 minus what is expectation of x? So what is m and k? Nothing but expectation of x power n into y power k. So what do you want here? U of x, nothing but expectation of x power 1 into y power 0. Therefore, n value is 1 and k value nothing but 0. So, m20 minus m10 whole square. So, already we have calculated m20. Now, we will calculate the first order moment m10, which gives the moment of the random variable, which gives the mean of the random variable x. Therefore, what is expectation of x? Nothing but m10. So, here n value is 1 and k value equals to 0. So, x power 1 into y power 0 into what is y power 0 value here? 1. So, into the joint density function. What is joint density function here? X plus y whole square by 40 into dx into dy. So, if you simplify this, you got the mean of the random variable x as 0, and similarly you can calculate the mean of the random variable y. So, what is the mean of the random variable y? Nothing but u of y. Nothing but what? Expectation of x power 0 into y power 1. Means n value is 0 and k value 1. Therefore, nothing but m01. So, you are calculating m01. So, you got it as what? 0. Now, we write down the variance of the random variable x. Since, what is the variance of the random variable x? Nothing but expectation of x square minus expectation of x whole square. Nothing but m20 minus m10 whole square. So, what is m20 got previously? So, you got m20 is equals to 9 by 25 minus, so 9 by 25 minus what is m10 you got? Nothing but 0. So, 0 whole square, then nothing but what? 9 by 25, which is equals to what? 0.36. Similarly, what is the variance of the random variable y? Sigma y square is nothing but expectation of y square minus expectation of y whole square. Nothing but what is expectation of y square? Nothing but m02 minus m01 whole square. So, what is m02? We have already calculated here. That value is equals to 5.16. So, 5.16 minus what is m01 you got? Nothing but 0. So, 0 whole square, that equals to what? 5.16. Therefore, what is the first bit you got? The variances of the random variables x and y. Now, what is the second bit? You have to calculate the correlation coefficient of the two random variables x and y. What is the formula here? The correlation coefficient of two random variables x and y, rho xy is equals to what? Expectation of x minus mu x into y minus mu y by square root of u of x square minus u. It means previously I written the formula here. What is the covariance formula written? Rho correlation coefficient rho xy is equals to what? Cxy by sigma x into sigma y. So, Cxy nothing but what? The covariance formula. What is covariance formula? Expectation of x minus x bar into y minus y bar. If you simplify this, what can you happen here? U of xy minus x bar into y bar. What is sigma x? Square root of expectation of x square minus x bar square. What is x bar? We got here 0. And here we got y bar is equals to 0. Therefore, what is sigma x equals to square root of e of x square, and what is sigma y here? Square root of e of y square here in this problem. So what is e of xy got here? So e of xy minus e of x bar into y bar. So what is x bar y bar? You got here 0. Therefore you get the equation for correlation coefficient for this problem. Rho xy is equals to e of xy by square root of e of x square minus into e of square root of e of y square. Therefore what is m11? What is e of xy? m11 by square root of m20 into m02. Now substitute the values, then you are going to get the values what? The correlation coefficient value is equals to 0.44. And moreover, the correlation coefficient value will be from -1 to 1. Nothing but the minimum value is -1, the maximum value is nothing but 1. And second question here, if the joint density function of two random variables x and y is fxy of x comma y is equals to x plus y for the values of x is ranging from 0 to 1 and y is ranging from 0 to 1 and is 0 elsewhere, find the correlation coefficient. It means it is also same similar problem only, but only the function has been changed. So what is the joint density function of the two random variables? It is nothing but what? X plus y for what values of x? When x is from 0 to 1 and y is from 0 to 1 and it is 0 for other values of x and y. So what you have to calculate? Correlation coefficient. So what is the correlation coefficient formula? Nothing but rho xy is equals to what? Cxy by sigma x into sigma y, where what is Cxy? Nothing but the covariance. So what is the covariance formula? Expectation of x minus x bar into y minus y bar is nothing but u of xy minus x bar into y bar. U of xy is also called as what? Correlation. And what is sigma x? Nothing but square root of sigma x square. Nothing but square root of expectation of x minus x bar whole square. So if you simplify this, then you are going to get u of x square minus x bar whole square. And similarly, what is sigma y is nothing but square root of u of y square minus y bar whole square. So what is x bar? That is nothing but the mean of the random variable x, and what is y bar? That is nothing but the mean of the random variable y. So in order to calculate the correlation coefficient, what you have to calculate? You have to calculate the covariance. In order to calculate the covariance, you have to calculate what? The correlation, nothing but u of xy you have to calculate, and then you have to calculate x bar and y bar. What is x bar and y bar? The means of the variables x and y. Nothing but u of x and u of y you have to calculate. After that, you have to calculate the variances of the two random variables. In order to calculate the variance of the two random variables, standard deviation, first you have to calculate u of x square, and then you have to calculate u of y square. So first you will calculate u of x and u of y, that is nothing but x bar and y bar. Next one is you will calculate u of x square and u of y square. Next you will calculate the expectation of xy. After calculating this way, then you will write down the formula for correlation coefficient, and then you will calculate the correlation coefficient of corresponding random variables. Now we will solve the problem. So what is the covariance of the two random variables x and y? Cxy is equals to what? Expectation of xy minus u of x into u of y. Nothing but expectation of xy into x bar into y bar only. So first we'll calculate what? Expectation of xy. So what is expectation of xy? Nothing but how many random variables are here? Two random variables. And what type of the two random variables? They are continuous random variables. So for continuous random variables, what is the expectation of xy? That is nothing but what? Integration minus into infinity. Integration minus into infinity. And here xy is there. Expectation of, then write down here xy into the joint density function of the two random variables x and y. There is nothing but fxy of x comma y dx into dy. And what they are given the joint density function? So when it is from 0 to 1. What are the x values and y values? Y equals 0 to 1 and x is also from 0 to 1. Then what is joint density function they are given? X plus y. So into what we have here? Dx into dy. So if you simplify this, then you are going to get the answer here 1 by 3. This is nothing but what? U of xy. Next, in order to calculate expectation of x, so we are calculating what? The marginal density function of x. What is expectation of x formula? Since I have only one random variable, integration minus infinity x into fx of x dx. But they are not given the density function of the random variable x there, but they have given only the joint density function. Then how do you calculate this? By using the marginal density function formula. What is the formula here? If you want the marginal density function of the random variable x, then integrate the joint density function with respect to y for the limits minus infinity and infinity, so that you are going to obtain the marginal density function of the random variable x. Here first for calculate the marginal density function of the random variable x. So what is fx of x? That is equals to integration minus infinity fxy of x comma y into dy. So what are the y limits here? 0 to 1. And what is the density function here? X plus y into dy. So if you simplify this, so when you integrate with respect to y, the x terms will get constant. Then nothing but here x into integration of y, 1 is nothing but y, plus integration of y is nothing but y square by 2. And the limits are 0 to 1. You substitute, then you are going to get x plus 1 by 2. Then what is expectation of x formula? Integration minus infinity x into fx of x into dx. So the limits are the integration with respect to x. Therefore, what are the limits of x here? 0 to 1. So x into, and what is fx of x here? X plus 1 by 2 into dx. So you will get the answer 7 by 12. This is one way. RS can calculate like this also. So as we have done the previous problem, first calculate what is m and k. Nothing but expectation of x power n into y power k. So first you have to calculate the correlation coefficient. What is the formula here? Cxy by square root of sigma x into sigma y. What is Cxy? Nothing but what? The covariance formula is nothing but expectation of xy minus x bar into y bar. So in terms of the joint moments, we can write here m11 minus m10 m01. And what is sigma x? Nothing but sigma x square, nothing but what? m20 minus m10. And what is sigma y square? m02 minus m01. So you can calculate the joint moments about the origin and they can substitute here. RS, this is the other method to calculate the mean of the random variables x and y if the joint density function has been given. By calculating through joint moments, can calculate RS by calculating through the marginal density functions also can calculate the means of the random variables x and y. Similarly, you can calculate the marginal density function of the random variable y also. Then how do you calculate the marginal density function of the random variable y? So for that you have to integrate the joint density function with respect to the random variable y over the limits. So with respect to the random variable here x. So with respect to the random variable x, you have to integrate over the limits minus infinity comma infinity. So what is the joint density function? Nothing but they are given x plus y when x is from 0 to 1. Now you are integrate with respect to x. So when you integrate with respect to x, y term will become constant. So integration of x is nothing but x square by 2 with respect to x, and integration of y is nothing but y into x. When substitute the upper and lower limit, then you will integrate here y plus 1 by 2. Next, what is the expectation of y formula? Integration minus into infinity y into fy of y into dy. So what is the y here? Nothing but the limits are from 0 to 1. Therefore 0 to 1 y into what is fy of y here? Y plus 1 by 2. So if you simplify it, then you are going to get the mean of the random variable y as 7 by 12. Then what is the covariance formula here? What is u of xy got here? 1 by 3 minus the mean of the random variable x is 7 by 12 into 7 by 12. Then here nothing but minus 1 by 144. So this is what the covariance of the random variable x. And next what you have to calculate in the question? Correlation coefficient. So for correlation coefficient, you have to calculate u of x square and u of y square. After that, you have to calculate the variance by using this formula sigma x square and then sigma y square. After that, you have to substitute. So in the similar manner, how you have to solve the first problem? You have to calculate, after calculating the covariance, you have to calculate what? The variances of the two random variables, and then you substitute in the formula to calculate the correlation coefficient. The third problem is statistically independent random variables x and y have moments m10 is equals to 2, m20 is equals to 14, m02 equals to 12 and m11 is equals to minus 6. Find the moment m22. So what is n plus kth order joint moments about the origin? What is the formula? Mnk is nothing but expectation of x power n into y power k. So what is here m20? What is m20? Nothing but n value is 2 and k value nothing but 0. Therefore expectation of x square into y power 0. That equals to what? Expectation of x square. What is the value they are given in the problem? 14. Similarly, what is m10? M10 nothing but n value is 1 and k value equals 0. So expectation of x power 1 into y power 0 nothing but expectation of x that equals to what they are given here. M10 value nothing but 2 they are given. So write down here 2. Next what they are given here? M02. What is M02? N value is 0 and k value equals to 2. So expectation of x power 0 into y square. That equals to what? Expectation of y square. That equals to what? 12. Next what is M11? Expectation of x power 1 into y power 1. Nothing but u of xy. So what is u of xy? They are given here minus 6. So these are the given data. What you have to calculate? You have to calculate what? M22. So what is M22? Nothing but what? Expectation of x square into y square. So what is M22? Nothing but expectation of x square into y square. And moreover, what they are given? They are given that the two random variables are statistically independent. If they are statistically independent, then how can I write down here? U of x square into u of y square. How can I write? If they are independent random variables, can I write down expectation of x square into y square as what? Expectation of x square into expectation of y square. Therefore, so this is nothing but mu22. This is not m22, nothing but mu22. Then, what is u of x square value here? Nothing but 14 into what is u of y square? Nothing but 12. So 14 into 12. This is nothing but what? M22. And also you are calculating what? Mu22. So what is mu22? Nothing but this n plus kth order. The joint moments, the moments about the origin. Then what is that formula? Mu nk is equals to expectation of x minus x bar power n into y minus y bar power k. Then what is mu22 is nothing but you have to substitute n value as 2 and k value is also 2. So expectation of x minus x bar whole square into y minus y bar whole square. Then you can simplify this one. Then if you simplify this, then what you are going to happen here? Expectation of x square minus mu x square into expectation of y square minus y square. So why you are writing like this? Because they are given that these are independent random variables. For independent random variables, how can I write down here? Expectation of x minus x bar whole square into expectation of y minus y bar whole square. Mu y nothing but y bar, mu x is nothing but x bar t. So if you simplify nothing but the variance of the random variable. What is the variance of the random variable? If you simplify, you are going to get u of x square minus x bar square. X bar nothing but here mu x only. So u of x square minus mu x square into u of y square minus mu y square. What is the meaning of the random variable they are given here? U of x is 2 and they are not given here u of y. They are given u of x, they are given u of xy. Then how do you calculate the expectation of y? So what is the expectation of xy? If they are statistically independent, you can write this as what? U of x into u of y. So what is from this? What is u of x they are given? 2. What is u of xy they are given? Minus 2. So from this, what is u of y is equals to minus 3. Now we substitute u of x, u of y, u of x square and u of y square. Then you are going to get obtain the second order, the fourth order, because n plus k. Here 2 plus 2 equals what? Fourth order. The fourth order joint moment about the mean. Nothing but mu22 is equals to 30. Next question. For two random variables x and y, the joint density function is fxy of x comma y is equals to 0.15 into del of x plus 1 into del of y plus 0.1 into del of x into del of y plus 0.1 into del of x into del of y minus 2 plus 0.4 into del of x minus 1 into del of y plus 2 plus 0.2 into del of x minus 1 into del of y minus 1 plus 0.05 del of x minus 1 del of y minus 3. So what you have to calculate? Find the correlation, then another correlation coefficient, and third one you have to say whether they are uncorrelated or orthogonal. So first, how do you calculate correlation? Nothing but expectation of xy, nothing but correlation. Second one, how do you calculate correlation coefficient formula? Nothing but what? Cxy by sigma x into sigma y. What is Cxy? The covariance formula. What is the covariance formula? U of xy minus x bar into y bar by sigma x into sigma y. And what is the third one you have to calculate? You have to show that whether they are uncorrelated or orthogonal. If they are orthogonal or uncorrelated, then what can happen here? U of xy is equals to U of x into U of y. Or else you can write down, if the covariance is equals to 0, then you can say that they are uncorrelated or orthogonal random variables. So these are the three formulae you have to use in order to calculate the given data. So what do you have to calculate? You have to calculate the first bit is the correlation Rxy. So what is expectation of xy? Nothing but the correlation Rxy. So what is Rxy? Nothing but expectation of xy only. There is a formula integration minus infinity xy into fxy of x comma y dx into dy. Now substitute the given joint density function. Then here what do you have here? Integration of xy into what do you have here? Integration of x into y into del of x minus, let us say, k1, and here x y minus k2. So x minus k1 into y minus k2. So we have to generally having this one. Then what is the impulse function del of x formula? Nothing but what is defined? It is 1 at the origin and it is 0 elsewhere. This is the definition of what? Unit impulse function. Then what is del of x minus k1? Nothing but what? This is 1 when x equals to k1. When x equals to k1, so del of 0. What is del of 0 value? Nothing but 1. And it is 0 for other values of x. And similarly, what is del of y minus k2? Nothing but it is 1 when y is equals to k2 and 0 otherwise. So only at this values it is defined. Only at one value it is defined. Therefore, what is the integration of minus infinity to infinity xy into del of x minus k1 into y minus k2? Only this is defined only at x equals to k1. And this is only at y equals to k2. Therefore, k1 into k2 into 1 into 1. For remaining values of x it is 0. Therefore, what is the value here? k1 into k2. Next, what do? You just multiply this one, xy into 0.15 into del of x plus 1 into del of y plus xy into 0.1 into del of x into del of y plus 0.1 into xy into del of. So, if we simplify this, then what can happen here? 0.15 into what is k value here? Minus 1, here 0. Because x plus 1 can write as what? X minus of minus 1. Therefore, what is k1 value here? 1 and here k2 equals 0. So, 0.15 into minus 1 into 0 plus 0.1 into here k1 is 0. So, because x minus k1 and y minus k2. So, what is k1 here? 0 and here k2 equals 0. So, 0 into 0 plus 0.4 into here k1 is 1, k2 is minus 2 plus 0.2 into k1 is 1 and k2 is nothing but here 1. 0.2 into 1 into 1 plus 0.05 into k1 is 1, k2 is 3. So, 1 into 3. So, if you simplify this, then you are going to get the correlation as what? The first problem is minus 0.45. Then, so what can happen here? This is here 0. It is also 0. So, minus 0.8 plus 0.2 plus 0.05 into 3. Nothing but 0.15. So, here 0.35 minus 0.8. Nothing but minus 0.45. What is the answer here? Rxy is equals to what? Minus 0.45. This is the answer. This is the first bit. Now, second bit, what you have to calculate? You have to calculate the correlation coefficient. In order to calculate the correlation coefficient, already we have calculated the U of x with the correlation Rxy. You have to calculate the means of the random variables x and y, and then you have to calculate the variances. So in order to calculate this correlation coefficient, you will calculate the means of the random variables x and y, and then the variances of the two random variables x and y. Now what is U of x? Nothing but m10 only. What is m and k? It's nothing but what? Expectation of x power n into y power k, that equals to what? Integration minus into infinity x power n into y power k into fxy of x comma y into dx into dy. So in place of n you got here 1, in place of k you got here 0. So x power 1 into y power 0, nothing but what? X here. Therefore x into fxy of x comma y dx into dy. Now substitute the joint density function. If you simplify, then you got u of x equals to 0.5. In the similar manner, calculate u of y and then calculate the covariance cxy. Then in order to calculate the correlation coefficient, we have to require what? The variance. What is the variance formula? Sigma x square equals to u of x square minus u of x whole square. So already I have calculated u of x. Now calculate u of x square. And similarly to calculate variance of y, calculate u of y square by using the moments about the origin. Then substitute, then you will get the correlation coefficient as what? Minus 0.272. And what is the third problem? This is a second bit. And what is the third bit? You got here C bit. So whether are these random variables x and y are uncorrelated or orthogonal. For uncorrelation, what is the correlation coefficient of Cx should be 0. But here the covariance is not 0. That value is equals to minus 0.325. Since it is not equal to 0, the random variables x and y are what? Correlated. Or else can write down here, they are not uncorrelated. Not uncorrelated, I can say that are correlated. Since the correlation Rxy is not equal to 0, you can say that x and y are not orthogonal. What is Rxy? You got here the correlation value minus 0.45. Since that is not equal to 0, you can say that they are not orthogonal. Next question. Two random variables x and y have the joint characteristic function pi xy of omega 1 comma omega 2 equals to e power minus 2 omega 1 square minus 8 omega 2 square. Show that x and y are both 0 mean and that they are uncorrelated. So first what they have given? They have given the joint characteristic function. What you have to calculate? You have to calculate the means of the random variables are 0. It means in order to show that the mean of the random variable is 0, you have to calculate the mean of the random variable x, nothing but m10. And then you have to calculate the mean of the random variable y, nothing but what? m01. Next, what you have to show that they are uncorrelated. For uncorrelation, what is Cxy? The correlation is equals to 0. The covariance is equals to 0. Nothing but Cxy should be 0. What is Cxy formula? U of xy minus x bar into y bar equals to 0. Then implies what is U of xy? Nothing but x bar into y bar. Then you can say that they are uncorrelated. So first calculate m10, calculate m01, then calculate m11. After that, you have to show that if you get the value 0, can show that the means are 0. And if you get the covariance as 0, or else can show that m11 equals x1 y bar, then you can say that they are uncorrelated. Now, from the previously you are done by if they give the joint characteristic function, you have calculated the joint moments about the origin. But instead of giving the joint density function, they have given the joint characteristic function. Then how do you calculate the joint moments about the origin? Using this characteristic function, what is the formula for that? m1k is equals to what? Minus j power n plus k into dou power n plus k pi xy of omega 1 comma omega 2 by dou omega 1 power n into dou omega 2 power k. After differentiating, then you have to substitute omega 1 is 0 and omega 2 equals 0. So in order to calculate the means, you have to calculate what? m10 and m01. Now what is m10? Nothing but what? Expectation of x power 1 into y power 0. Nothing but what? Minus j power. Here n value is 1 and k value is 0. So minus j power n plus k. Nothing but 1 plus 0 into dou power n plus k into pi xy of omega 1 comma omega 2 by dou omega 1 power n. Just substitute in this formula, n value is 1 and k value equals to 0 here. So 1 into dou omega 2 power 0 when omega 1 equals 0 and omega 2 equals to 0. That equals to what? Minus a into dou. What is the differential? This characteristic function they are given e power minus 2 omega 1 square minus 8 omega square. E power minus 2 omega 1 square minus 8 omega 2 square by dou omega 1. After that, you have to substitute omega 1 equals 0 and omega 2 equals 0. So, you have differentiate with respect to what? Omega 1. Then, e power, you can write this as what? E power minus 8 omega 2 square. Since the differentiation with respect to omega, this is constant, make it outside. So, minus j into dou e power minus 2 omega 1 square by dou omega 1. After that, you have to substitute omega 1 is 0 and omega 2 equals to 0. Then what can happen here? Minus j into e power minus 8 omega 2 square. So differentiation of e power minus 2 omega 1 square is what? Minus 4 omega 1 into e power minus 2 omega 1 square. After that, you have to substitute omega 1 is 0 and omega 2 equals 0. So if you substitute omega 1 and omega 2 equals 0, then you are going to get what? 0. Therefore, what is m1 0? Nothing but the mean of the random variable x is 0. So similarly, calculate the mean of the random variable y. So what is m01? Nothing but expectation of y. So nothing but here n value is 0 and k equals to 1. Then what is the formula here? m01 is equals to dou power 0 plus 1 minus j power 0 plus 1 into dou power 0 plus 1 pi xy of omega 1 comma omega 2 by dou omega 1 power 0 because n is 0 and k equals to 1. After that, you have to substitute omega 1 is 0 and omega 2 is also 0. Then u of y, nothing but what? m01 is equals to minus j into dou by dou omega 2 because omega 1 power 0 nothing but this value is 1. And what the characteristic function here? E power minus 2 omega 1 square minus 8 omega 2 square. After that, you have to substitute omega 1 and omega 2 equals to 0. So if you simplify this, then you are going to get u of y is equals to 0. Therefore, the first condition is what? The means are 0. The first condition is satisfied. And what is the second one you have to show? You have to show that they are uncorrelated. For uncorrelation, what you have to show? You have to show that u of xy is equals to u of x into u of y because the covariance is 0 for them. So already you calculate u of x and u of y. So calculate u of xy. So what is u of xy? Nothing but m11. What is m11? Dou power, minus j power 1 plus 1 into dou power 1 plus 1 pi xy of omega 1 comma omega 2 by dou omega 1 power 1 into dou omega 2 power 1. After that, you have to substitute omega 1 and omega 2 equals 0. So if you simplify this, then you are going to get it is 0. And what is u of xy? 0. And 0 into 0 nothing but 0. Since it is satisfied, then you can say that x and y are uncorrelated random variables. Next one is what? Calculate the following. The variance of the sum of x and y. Second one, the variance of the difference of x and y for two random variables. X and y have 0 mean and variances sigma x square equals 16 and sigma y square is equal to 36 and the correlation coefficient is 0.5. So what they are given that? They are given that x and y are two random variables and they have 0 mean. Nothing but what? What is u of x? Nothing but x bar is 0 or I can write mu x also. And similarly, what is u of y? Or y bar is equals to 0 and they have given the variances sigma x square equals 16 and sigma y square equals to 36 and the correlation coefficient rho xy is equals to 0.5. Now what you have to calculate? You have to calculate the variance of the sum of x and y. Nothing but sigma x plus y whole square. Then what is the formula for sigma x plus y whole square? Expectation of x plus y. What is sigma x square formula for the random variable x? u of x minus x bar whole square. If you simplify, what can happen here? U of x square minus x bar square. Similar here, u of in place of x, you have x plus y. So u of x plus y whole square minus x plus y whole bar, because in place of x, here have x plus y. Therefore, x plus y whole bar. Nothing but what? Expectation of x plus y only. So what they are given that the means are 0 and they are given the variances. So you have to calculate what? You have to calculate the variance of sum of x and y and the variance of the sum of y. So now, so what is the variance of sum of x and y? Nothing but u of x plus y whole square. What is u of x plus y whole square? Nothing but what? U of x square plus y square plus 2xy minus what is u of x plus y? Nothing but u of x plus u of y. But what is u of x plus y? Nothing but here 0, because u of x is 0 and u of y is also 0. Then you can write this as what? U of x square plus u of y square plus 2 into u of xy. And equals to what is u of x square value? So they have given the variance nothing but u of x square minus x bar square is equal to 16. Since x bar is 0, u of x square equals to 16 only. So 16 plus 36, similarly plus 2 into, so and they have given the correlation coefficient. What is that value they have given? 0.5. So cxy by square root of sigma x into sigma y. So what is correlation coefficient they are given? 0.5 is equals to cxy by what is sigma x here? 16 square root of and then 36. Nothing but 0.5 into 4 into 6 is equals to cxy. So what is cxy from this? Nothing but u of xy minus x bar into y bar is equals to, it's nothing but, here it is nothing but 12. So from this they have given x bar y bar is 0. Then what is u of xy is equals to what? 12. Therefore 2 into 12. Then you are going to get here 16 plus 36 plus 24. It is nothing but here 76. Similarly, what is the variance of the difference of the two random variables? Nothing but sigma x minus y whole square. What is sigma x minus y whole square? Expectation of x minus y whole square minus x minus y whole bar. So what is this value? Since the means of the two random variables are 0, this value is equal to 0. Then what is the expectation of x minus y whole bar? Nothing but x square plus y square minus 2 into xy. Therefore, for the second bit, we are going to get sigma x minus y whole square is equals to what? U of x square plus u of y square minus 2 into u of xy. Now substitute u of x square is 16 and u of y square is 36, and what is u of xy got? 12. Then you will get the variance of the difference of the two random variables. And the next question is what? The joint density function of the random variables x and y is fxy of x comma y is equals to 1 by 100 when x is from 0 to 5 and y is from 0 to 20. So and is 0 elsewhere. Find the expected value of the functions xy, x square y and xy whole square. So what they are given here? They have given the joint density function of two random variables which is given by 1 by 100 when x is from 0 to 5 and y is from 0 to 20 and it is 0 otherwise. So what is the first one you have to calculate? Expected values of functions xy, nothing but u of xy. What is u of xy? What is the formula for this? So integration minus infinity, since you have two random variables, write down here integration minus infinity, then the xy into fxy of x comma y into dx into dy. So what are the limits of x is from 0 to 5 and the y limits from 0 to 20. So x equals 0 to 25 and y is equals to 0 to 20. So xy into, in this limit what is the density function here? 1 by 100 into dx into dy. So if you simplify this, then we get here u of xy. Then what can happen here? Integration 0 to 5x into, here 1 by 100 is constant, bring it outside. So integration of y is nothing but y square by 2, the limits are from 0 to 20 into dx. That equals to 1 by 100 into integration 0 to 5 x into substitute the lower upper limits, then we are going to obtain 20 square. What is 20 square here? 400 by 2 into dx. Then you are going to get 2 into integration 0 to, what are the limits of x here? 5. So 0 to 5 x into dx, that equals to 2 into x square by 2 from 0 to 5. That equals to what? 25. And similarly, what is the second bit? You have to calculate expectation of x square y. So expectation of x square y in the similar manner you can calculate here. So integration minus into infinity. So in place of x and y, you have now x square into y. So x square into y into fxy of x comma y into dx into dy. Now the limits of x is from 0 to 5 and y limits are from 0 to 20. So x square into y into here, the density function is 1 by 100 into dx into dy. Now simplify this, then you are going to get what? Expectation of x square. That implies, so integration 0 to 5, 1 by 100 is constant. So x square into integration of y with respect to y nothing but what? Y square by 2, and the limits of y is from 0 to 20 into dx. That equals to 1 by 100 into integration 0 to 5 x square into here 20 square by 2, nothing but what? 400 by 2 into dx. So 2 into integration of x square, nothing but x cube by 3 from 0 to 5. That equals to what? 125 by 6 here. So this is nothing but u of x square y. And what is the third bit? You have to calculate u of xy whole square. So u of xy whole square. What is u of xy whole square? So integration minus infinity xy whole square into fxy of x comma y into dx into dy. Where the limits of x is here 0 to 5 and the limits of y are from 0 to 20. So x square into y square, xy whole square, nothing but what? X square into y square into, the density function is here 1 by 100. So if you simplify this, so 1 by 100 is constant. So x is from 0 to 5, x square into, so integration of y square, nothing but y cube by 3 and the limits are from 0 to 20 into dx. That equals to 20 cube by 3 into 1 by 100 into integration of x square, nothing but x cube by 3 and the limits are from 0 to 5. That equals to 20 cube by 3 into 1 by 100 into 5 cube by 3. So this is the answer for what? U of xy whole square. So next question is, prove that any two random variables x and y, the inequality mod of sigma xy is less than or equals to sigma x into sigma y is true. So in order to prove this, so what is sigma x? Nothing but what? Covariance. Nothing but what? Which is called as what? Covariance. Nothing but what? Standard deviations of x and y and the random variable y. So in order to prove this relation, first you have to consider one equation, nothing but what? Expectation of y minus mu y. What is mu y here? The mean of the random variable y, nothing but what? Y bar only. Minus a into x minus mu x whole square. So this is the expectation of y minus y bar minus a into x minus x bar whole square. So expectation of any some function square, nothing but what is expectation? Nothing but what? Average. So if you square and then take the average, that value is always greater than or equals to nothing but positive value only. If you square and then if you calculate the average, it is always positive only. That is what? It is always greater than or equals to 0. Now write the formula as what? This is like a minus b whole square formula. So a square plus b square minus 2ab. In place of a, y minus y bar. In place of b, a into x minus x bar. Then to simplify this equation, then what is expectation of y minus y bar? Nothing but the variance of y. What is the expectation of x minus x bar? Variance of x. What is the expectation of y minus y bar and x minus x bar? Covariance of x and y. Now here take the common sigma x square from this equation. Then what can happen here? A square minus 2a covariance of x and y by sigma x square, which is greater than or equals to 0. Now how we are writing this equation? We are writing this equation as what? A minus b whole square minus covariance of x comma y by sigma x square whole square. So if you simplify this one, a minus b whole square nothing but what? A square plus b square. What is b square? Covariance of xy by sigma x square minus 2a into covariance of xy by sigma x square. And here that plus and minus will cancel together same only. So I am rewriting this equation like this. Then after that, you just take LCM of this. Then what can happen here? Sigma x square into sigma y square minus covariance of this plus sigma x square into here. So this is squaring. Therefore, this value is always positive. In order to make this expression valid, this numerator should be always positive. Therefore, sigma x square minus sigma y square minus covariance of xy should be always greater than equals 0. From this, covariance of xy is always greater than equals to what? Sigma x into sigma y. Nothing but what here? The covariance is represented by sigma xy also. Next question. Find variance and covariance of x minus 2y if u of x equals to 2, u of y equals to 3 and u of xy is 10, u of x square equals to 9 and u of y square equals to 16. So what they have calculated? You have calculated the variance and covariance of x minus 2y. So what is the variance of x and here? Nothing but what? Sigma x square nothing but u of x square minus u of x whole square. So what they are given here? U of x square value they have given as what? 9. U of x is nothing but what? 2. Then what is the variance of x? 5. So 9 minus 2 square nothing but what? 5. What is standard deviation here? Square root of 5 nothing but what? 2.24. Similarly, find out the variance of y. From that, find out the standard deviation of y. Then what is the correlation quotient formula? Rho xy is equals to covariance of x comma y by sigma x into sigma y. So from this, what is rho xy equals to covariance? What they have given here? Covariance they have given as what is covariance? U of xy minus u of x into u of y. What is u of xy here? 10 minus u of x is 2 and u of y is 3. Therefore, 4 by sigma x into sigma y. Then you got the correlation coefficient of the two random variables x and y. Then you have to calculate what? Variance and covariance of x and x minus 2y. So x minus 2y nothing but what? Variance of x minus 2y whole square, and then you have to calculate the covariance. So variance and covariance of x minus x and y. Variance of x and y and covariance of x and y you have to calculate here. So next problem is the density function of two random variables x and y is fxy of x comma y equals to xy by 9 when x is from 0 to 2 and y is from 0 to 3. Then what you have to show? You have to show that x and y are independent. You have to show that they are uncorrelated. For independent, statistically independent, what you have to show? You can show that fxy of x comma y equals to what? Fx of x into fy of y. For uncorrelated, what is the condition? U of xy is equals to u of x into u of y. So prove these conditions to show that they are uncorrelated and they are statistically independent. For statistically independent, you have to calculate fx of x and fy of y. Nothing but the marginal density function of x. Similarly, you have to calculate the marginal density function of y. So since it is nothing but fx of x and fy of y is equals to the joint density function, you can say that x and y are what? Statistically independent. Next, what you have to show that for uncorrelated, u of xy is equals to u of x into u of y. So calculate u of xy, then calculate u of x, and calculate u of y. If these two are equal, then you can say that they are uncorrelated. Now, what is u of xy? Integration minus infinity xy into fxy of x comma y dx into dy. You got 8 by 3. Then what is u of x? Integration minus infinity. So expectation of x is nothing but x into fx of x. Substitute, then you are going to get here 8 by 6. Then u of y equals to 2. Then what is u of x and u of y? Nothing but 8 by 3. And what is u of xy got? 8 by 3. Since those two are equal, then you can say that x and y are what? Uncorrelated random variables. Next question. Let two random variables y1 and y2 be linear transformations of x1 and x2 given by y1 equals to x1 plus x2 and y2 equals to 2x1 plus 3x2. If the joint density function, nothing but fx1, x2 of x1 comma x2 is a joint density function of x1, x2. Find the joint density function of y1 and y2. It means what they are given that x1 and x2 are two random variables. So by performing the linear transformation or some operation on this, they are going to get two new random variables. What is y1? Nothing but by performing the operation on x1, x2. What type of operation they have performed here? Just they have added so that they got a new random variable y1. Similarly, what is y2 equals to? By performing the operations on x1, x2, you got what? The new random variable y2. So what you got here? 2 x1 plus 3 x2. So if fx1, x2 of x1 is a density function, then you have to calculate the density function of the transformed random variables. What is the formula here? If there are n random variables, then what is the formula? F y1, y2 and so on, yn of y1 to yn equals to what? Fx1, x2 and so on, xn of x1 equals to t1 inverse and so on, xn equals to n inverse into mod j. Here what is j is called as Jacobian matrix. So it is called as what? Jacobian matrix. Nothing but you have to calculate the determinant of the Jacobian matrix. What is Jacobian matrix? It is a n by n matrix, n rows and n columns. Nothing but dou t1 inverse of by dou y1 and so on, dou t1 inverse of dou n by, and so this is, if it is n random variables, it is n by n. If there are two random variables, then how can you write down the equation here? F y1, y2 of y1 comma y2 is equals to fx1, x2 of x1 equals to t1 inverse and x2 is equals to t2 inverse into mod of j, where what is the Jacobian matrix? Nothing but determinant, nothing but dou t1 inverse by dou y1, dou t1 inverse by dou y2. This is the first row. Note the second row, dou t2 inverse by dou y1. So dou t2 inverse by dou y2. So what is t1 inverse? So T1 inverse nothing but what? T1 inverse of y1 comma y2. Nothing but what? We are going to get the random variable x1. How do you get y1? By performing the transformation on x1, x2. Similarly, you want the x1 random variable. So by performing the inverse operation on these two random variables, then you are going to get what? The random variable x1. Then what is x2 is nothing but T2 inverse of y1 comma y2. Then so they have given from this we have to calculate x1 and x2. So what is y1 is equals to they have given x1 plus x2. And what is y2 is they have given 2x1 plus 3x2. So 2x1 plus 3x2. So then by simplifying this, I'll write down in terms of x1 and x2. So you're having two equations. You're having two unknowns x1 and x2. You have to calculate. Then how do you calculate? We just multiply this with 2. Then you get 2y1 equals to 2x1 plus 2x2. Here y2 is equals to 2x1 plus 3x2. So if you subtract and go so then get 2y1 minus y2 equals to minus x2. So from this what is x2 is equals to minus 2y1 plus y2. This is nothing but what? x2. T2 inverse of y1 comma yn. Similarly, you have to calculate x1 also. How do you calculate x1 here? So for you have to calculate x1, multiply this equation with 3. Then what can you obtain here? 3y1 is equals to 3x1 plus 3x2. What is y2 expression? 2x1 plus 3x2. 2x1 plus 3x2. Now subtract on both sides. Then what can you obtain here? 3y1 minus y2 is equals to x1. So therefore what is x1 equals to 3y1 minus y2. Nothing but what? T1 inverse of y1 comma y2. And what is this? Nothing but x2 is equals to T2 inverse of y1 comma y2. Now find out the Jacobian matrix. So what is J is equals to determinant of Jacobian matrix. So first one, what you have to do? Dou T1 inverse by dou y1. So what is T1 inverse here? Nothing but 3y1 minus y2. So with respect to y1, you have to differentiate. So if you differentiate, so what do you get here? T1 inverse, you got what? T1 inverse is equals to, okay, 3y1 minus y2. Differentiate with respect to what? Here y1. So this is the partial differentiation. Therefore, since it is partial differentiation, this is constant. Differentiation of any constant is 0. Therefore, 3 here. And next, here with respect to y2, nothing but here, this is constant is 0. So minus 1. And second one, here minus 2 and 1. So minus 2 and 1. So if you calculate, you get 3 minus of minus 3 equals to what? 1. So therefore, what is a joint density function of the transform random variables? F(y1, y2) is equals to what? Fx1 comma x2 of x1 is equals to t1 inverse. What is t1 inverse here? 3y1 minus y2. So 3y1 minus y2 comma x2 is equals to, what is x2 value here? Minus 2y1 plus y2. So minus 2y1 plus y2 into mod of j. What is mod of j is equals to 1. Therefore, f(y1, y2) of y1 comma y2 is equals to fx1, x2 of x1 is equals to 3y1 minus y2 comma x2 equals to minus 2y1 plus y2. So this is what the joint density function of the transformed random variables. Next one, consider two random variables x and y such that y is equals to minus 4x plus 20. The mean value and variance of x and y are 4 and 2. Find the correlation between x and y and comment on the result. So what they are given, that they are given y is equals to minus 4x plus 20. And moreover, they are given the mean value of x, nothing but u of x equals to 4 and variance sigma x square equals to 2. What you have to calculate? You have to calculate the correlation between x and y, nothing but rxy, nothing but what? U of xy. So u of x into what is y here? Minus 4x plus 20. So that equals to what? U of minus 4x square plus 20 into x. That equals to what? Minus 4 into u of x square plus 20 into u of x. It equals to minus 4 into, what is u of x square? What is the variance formula? U of x square minus x bar whole square. So from this, what is u of x square equals to sigma x square plus x bar square. So sigma x square plus x bar square plus 20 into u of x. What is u of x value here? 4. So that equals to minus 4 into, what is variance they are given here? 2 plus the mean is 4. So 4 square plus 20 into 4. That equals to what? Minus 4 into, here 16 plus 2, nothing but 8. 18 plus here 80. So 18 into 4. So minus 72 plus 80. That is nothing but what? 8 is the answer. Next question. Two random variables x and y have the means. So they have given the means of the two random variables. And the variances they have given. They have given the correlation coefficient. What you have to calculate? You have to calculate they have defined two new random variables v and w. So you have to calculate the correlations of v and w and then correlation coefficient v and w. So how do you, what is the first problem you have to calculate? Correlations of v and w. Nothing but RVW. What is RVW? Nothing but expectation of v into w. Nothing but what is v value? Minus x minus y into 2x plus y. So from this you simplify, you get what? The correlation between v and w. And what is the b bit? You have to calculate correlation coefficient of v and w. What is the formula here? The covariance between v and w by standard deviations of v and w. So find out the covariance and then standard deviation, so that we are going to obtain the correlation coefficient of v and w, which we have done previously. Next one is, so they have given two random variables x and y, and then they have transformed into two new random variables x1 and y1 by using the coordinate notation x cos theta plus y sin theta and y1 equals to y cos theta minus x cos theta, x sin theta, where theta is a rotation angle. What you have to show that the angle of rotation, nothing but what? Theta equals 1 by 2 tan inverse of 2 rho sigma x into sigma y by sigma x square minus sigma y square. And what they are given that these random variables have to be transformed into uncorrelated random variables. It means here x1 and y1 are what? Uncorrelated random variables. For uncorrelated random variables, the covariance is equal to 0. So first find out the covariance of x1 and x2. So then substitute here x1 and similarly substitute the here y2. Then you can obtain after the covariance, make it equal to 0. So if you make equal to 0 for uncorrelated value, then you get the angle of rotation theta equals to what? 1 by 2 tan inverse of 2 rho sigma x sigma y by sigma x square minus sigma y square. Next one is they have given what? Two correlated random variables variances. They have given the variances of two random variables and then they are transformed into uncorrelated by the angle of theta equals to pi by 8. So what do you have calculated? You have calculated the correlation coefficient. So previously I have seen what is angle of rotation if they are uncorrelated transformed random variables 1 by 2 tan inverse of 2 rho sigma x sigma y by sigma x square minus sigma y square. So from this write the equation for rho. Then substitute the values, then you are going to obtain the correlation coefficient of the two random variables x and y. Next one is two Gaussian random variables x1 and x2 have zero mean and variances they are given and the covariance of the two random variables they are given. What you have to calculate? You have to calculate the covariance of new random variables y1 and y2 and what is y1 is equals to x1 minus 2x2 and what is y2 equals to 3x1 plus 4x2. What they have given that x1 x2 are zero mean, nothing but u of x1 is 0, u of y1 equals to 0. Then what is u of x1 square? Nothing but sigma x1 square only. And what is u of x2 square? Sigma x2 square only. Then what is the covariance is equals to correlation 3 only. Then what is the expectation of y1? So expectation of y1 is nothing but expectation of x1 minus 2x2. It is nothing but what? U of x1 minus 2 into u of x2. But what is u of x1 x2 is 0. Therefore, what is u of y1 equals 0. Similarly, what is u of y2 is also 0. Then calculate what? Covariance. Then what is c y1 y2 equals to u of y1 y2. So what is the covariance c y1 y2 equals to expectation of y1 y2 into y1 bar into y2 bar. But what is y1 bar equals to 0 and y2 bar equals 0. Therefore, what is c y1 equals to u of y1 into y2. So what is y1? x1 minus 2x2 and what is y2? 3x1 plus 4x2. So if you simplify, then you are going to get the answer minus 66. So like this, today in this class we have discussed about the problems on the expectations and the transformations of multiple random variables. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.